Hi, in today's class we're going to be talking about alkyl halides and how they can act as leaving groups in reactions. So first let's look at alkyl halides. So these are carbon atoms bound to halogens. So halogens can be like fluorine, chlorine, bromine, or iodine. And when we think about alkyl halides, we often categorize them in terms of what type of carbon they're bound to. So you can have a methyl halide here, a primary alkyl halide where the carbon is bound to two hydrogen atoms, a halogen, and another carbon, a secondary halide where the carbon is bound to one hydrogen, two R groups, and a halide, or a tertiary halide where this carbon is bound to three other carbon atoms and a halogen. So one of the things that makes alkyl halides so important for organic chemistry is that they are bond-making and breaking machines. They are very valuable assets in substitution and elimination reactions. So for example, there are several classes of substitution reactions that we're going to talk about later in this chapter in other videos. They're both categorized as with this capital S and the subscript N, substitution nucleophilic, where you can have a nucleophile directly displace the alkyl halide, or the alkyl halide can leave first and then a nucleophile can come in to make a bond. There's another class of reactions as well, eliminations. That's going to be covered in the next chapter, in the next section. And those elimination reactions, you'll see there's a common intermediate in this case, where a base comes along and abstracts a proton to give you now a double bond, or a base can come along to this molecule, deprotonate, and provide you with a double bond. Now, a commonality across all of these reactions, as you notice, is that they all have this leaving group. They all have this halogen, and we call it a leaving group because this is a portion of the molecule that has broken away from the main carbon side chain. So we have to look at what makes a good leaving group. So good leaving groups can be thought of as stable on their own. And so another way of thinking about that is to think of stable anions. And then we learned about this in the context of acids and bases. So stable anions are conjugate bases of strong acids. So for example, iodine, or iodide rather, is a great leaving group. It is the most stable of the acid, or the most acidic of the acids of HI versus HBr versus HCl versus HF. And that's because the iodide is the most stable of these anions. There's another kind of anion, another way of thinking about this is that they're also, you can view these as weak bases if you prefer to think about it that way. There are some other molecules as well that we can think about as being stabilized. So in this case, this sulfonate anion, this oxygen has the ability to resonate with the other oxygen atoms on this molecule, making it a really good leaving group. And we'll look at that in a couple chapters. Another molecule that is typically a good leaving group is actually water, or an alcohol like methanol or ethanol. And these ones are a little bit less intuitive. But let's first look at what's a bad leaving group. So hydroxide is a strong base, and it is a bad leaving group. You don't want to have hydroxide leaving your molecule in these particular reactions. It's a common error. So a lot of times people get confused because they think of water and hydroxide as perhaps synonymous, but really the water leaving as a neutral leaving group means that it is the conjugate base of this hydronium ion, and that is the hydronium ion is actually a strong acid. So again, if this is leaving the molecule as a neutral molecule, it is quite stable in doing so. All right, well, thank you for your time, and I look forward to seeing you in the next video. Thanks.